About 4.6 billion years ago, our Earth emerges. Since then, it's been shaped by the forces of nature. One element becomes the elixir of life for our planet: water. It's the origin of all life. And without it, there would be no human civilization. The first advanced cultures blossom along rivers. Houses are built with bricks made of water and earth. The use and the distribution of water become the driving force of state building. Settlements by the sea grow into prospering communities. Today, they're endangered. We have even built cities in the desert, a feat only made possible by bringing in water from hundreds of kilometers away. However, it has become scarce in many places, and will become ever more so as the world's population increases. Beaches are turned into dumping grounds, which pass on poisonous substances into the oceans. Our waste has long entered the cycle of life.
Changes in ecosystems, greater sedimentation rates, intense rainfall, global warming, all of these things have happened all together many times in the history of the planet. But we know what the cause of our perturbation is. It's us.
Water is an adaptable substance. Its overall amount on Earth, however, always remains the same. Water merely shifts into other shapes, the so-called states of aggregation. It's only due to this adaptability that the natural cycle, which constantly supplies Earth with fresh water, is possible in the first place. Water circulates from the mountains to the rivers and into the oceans, and it never dries up. A global view of Earth, made possible by spaceflight, reveals its uniqueness. Water makes it the blue planet. More than 70% of the surface of the Earth is covered by water. Solar irradiance causes it to vaporize and to form clouds. When they're cooling off, it begins to rain, since cold air stores less water than warm air. Rainfall is absorbed by plants and vaporized by them in turn. It's a constant cycle. The immense rainforests of the Amazon basin, 1.5 times the size of the European Union, play their part in the hydrological cycle too. Plants draw water from the soil, then their leaves emit it as vapor into the atmosphere, from where it's returned to them as rain. In this way, the gigantic forests regulate their precipitation themselves. Without trees, water would trickle away or run straight into the oceans. The overall amount of water on the planet remains constant, 1.4 billion cubic kilometers.
Es gibt reichlich Wasser auf der
There's
Erde.
ample water on Earth. Most of it is salt water. If we put all the water in a litre bottle, then just a few sips, about 30 millilitres, would be fresh water. And most of that would be ice or snow. So we have very little fresh water available for all living beings.
A part of it is stored in aquifers the world over, water containing layers of rock up to 5 kilometers deep. This so-called fossil water has been there for thousands of years and renews itself very slowly. Modern technology has made it accessible. Some decades ago, Saudi Arabia was one of the biggest wheat exporters in the world, thanks to groundwater, which allowed crops to grow. But today, the dream of a blossoming desert state is over. The time-old reservoir is as good as exhausted. Groundwater also gave life to the Mar del Plástico, the Sea of Plastic in southern Spain. It's the largest agglomeration of foil-covered greenhouses worldwide, extending over almost 360 square kilometers. Without groundwater, agriculture in this desert-like landscape wouldn't have been possible. Yet, here too, it's close to exhaustion. That's why water is brought in from the north of Spain by pipes. Each year, about 3 million tons of greenhouse vegetables are grown in Europe's largest winter garden. Helped by chemicals, especially fungicides, which not only have an impact on the vegetables, but also seep into the groundwater. We owe low-priced tomatoes not merely to our exploitation of nature. Some 90,000 cheap labourers toil in the foil-covered greenhouses, mostly seasonal workers from Africa. Many of them earn much less than the minimum wage. A large part of the harvest ends up in the countries of the EU and ensures a constant range of goods, regardless of the seasons. Consumption of water per capita varies greatly from country to country. In large parts of Africa, it's considerably lower than in most industrialized countries. Modern metropolises are consuming water on a gigantic scale. New York City, with its 9 million inhabitants, for instance, needs water in excess of 5 billion litres per day. What's more, a good part of it must be brought in over distances of more than 100 kilometres. Around the year 1900, supplying the fast-growing city requires an altogether new approach. The New Croton Dam, 35 kilometres north of New York, is at the time the highest dam in the world. The water is carried by aqueducts into huge reservoirs in the city. At the time, they were masterpieces of engineering. Today, New York's conduits supply the city's inhabitants with an amount of water that would fill 178,000 tanker trucks each day. From its sources, the water reaches the 6th floor of buildings by natural gravity alone. However, where there is no sophisticated system like this, water has to be distributed by hand.
Well, that's half a penny then.
For much of the 19th century, men like Johann Wilhelm Benz carry potable water from public wells right up to the door in buckets.
Careful.
Benz has found posthumous fame as the archetypal water carrier in a city like Hamburg. He's an easy target for the children who tease him on his rounds. That's how his story has gone down in folklore.
Leave me alone. Eat it, I said. Little pest.
Only after his death in 1854, is his hometown gradually provided with a central modern water supply, albeit for the time being without a filtration system. Back then, people are unaware of the danger posed by polluted water. As they see it, diseases have always originated from bad air.
During the Middle Ages, people had no idea of the actual origins of febrile diseases. They suspected parasites or the so-called miasma, polluted air, which contained and transported germs. There was a general notion that something within these fumes caused illnesses. However, they didn't yet know what this was.
As early as the 17th century, it becomes possible to discern what's hidden in a single drop of water. A lens grinder by the name of Antony van Leeuwenhoek succeeds in producing microscopes capable of magnifying an object by 270 times its original size. Among other things, he discovers bacteria, yet it's still a long way until their importance is understood. In 1892, cholera rages in Hamburg. For the last time in Germany, almost 9,000 people die because polluted water from the river has been used as drinking water. It's only then that a filter plant is finally installed.
With Hamburg, there's an additional problem. The ebb tides of the Elbe River may take the sewage with them. At high tides, however, they are pressed back into the canals. So the dirt gets stuck and causes bacterial pollution, which in turn causes cholera.
Robert Koch, even back then world famous as a bacteriologist, states that he had never seen living conditions as unhealthy as those in Hamburg. He calls the water supply system a breeding ground for germs.
How long has it been like this?
You might forget, he writes, that this was a European city. Only now did the city elders react and have modern filter plants built for all of Hamburg. In 2020, access to clean water is recognized as a human right by the Assembly of the United Nations. In view of its scarceness, new technologies are becoming ever more important. For instance, by the desalination of seawater, as it's practiced at Carlsbad, California, on an industrial scale. Here they filter salt out of the water using high pressure and fine-pored membranes. Meanwhile, the plant supplies 300,000 households. Recycling, too, plays an ever greater role. Again, California leads the way. In a suburb of Los Angeles, sewage water is purified in several stages by microfiltration. Reverse osmosis and disinfection by ultraviolet light turn sewage into clean water again. Only in this way will there be sufficient drinking water for our cities in the future. More than 2 billion people do not have access to clean water. It's particularly limited for many Africans. Water pollution is a global problem. It affects the oceans too. Above all, those close to a metropolis. It affects the fishermen as well. Of their once large fleet off New York, only a handful of boats is left. They're the last of their kind. In the past, the Hudson River was considered a marine ecosystem of outstanding richness. Millions of oysters helped to keep New York's waters clean, until, due to overfishing and pollution, there were hardly any left. Peter Malinowski has set himself the task of bringing back the oysters which once made New York famous.
New York Harbor used to be full of oysters, 200,000 acres of oyster reef. It was the dominant habitat type in the harbor. And back at that time, 500 years ago, the harbor was also full of fish and other marine life, and the oysters are the keystone species in that ecosystem. So when Europeans first arrived in New York Harbor, there were so many fish that you could catch them just by lowering a basket over the side of the boat and pulling it back up. So the harbor was actually literally full of live animals.
And their living sewage works. A single oyster filtrates 240 liters of water each day and even absorbs pollutants. Yet these days, it's anything but easy to find oysters in the waters off New York. That's why the helpers of the Billion Oyster Project have to collect oyster shells in New York's restaurants and plant them in floating cages on artificial reefs, hoping that the larvae will nest. They are not destined for the dinner table. First, the water must become cleaner.
We hope that by restoring oyster reefs, we can return those ecosystem functions, the services that they provided traditionally. So oysters filter the water, they provide food and habitat for thousands of animals, they stabilize the bottom, and they can protect the shore from storm events and wave action.
A tiny mussel as protector of a mega city. It wasn't called the Big Oyster for nothing. Water is our elixir of life. Yet it can also unleash enormous forces. Since ancient times, man has learned to put these forces to good use. As in the Upper Harz Mountains, a region of Germany, where 300 years ago they reshaped an entire landscape by harnessing water. The result is an immense, sophisticated system of artificial ponds, tunnels and canals to use hydropower for mining. It's unique the world over and has been declared a World Heritage Site by UNESCO.
This is groundwater that's coming in here. The amount is practically the same in summer as in winter, about 300 litres a minute. That's roughly 400,000 litres a day.
The immense mass of water must be brought back to the surface. But how? As early as 1700, the shafts extend to a depth of more than 300 meters. At first, it's done by hand using buckets, ladders and ropes. A wearisome job. But then engineers hit upon an ingenious solution: to exploit the force of water. They install wheels, which drive mechanical pumps and allow for multiple use of hydraulic energy. Thus, they create the biggest pre-industrial energy system ever, an incredible feat of engineering.
This is called a reversible wheel. It's a water wheel that can switch its direction of rotation. A rope is wound up and the pit cage is drawn upwards, while at the same time a second rope uncoils and the other cage goes downwards.
Due to this technique, the Harz becomes the biggest mining area of Germany in the 18th century. The dimensions of the site are impressive even today. 65 ponds for damming up water, as well as about 100 kilometers of trenches and watercourses are still to be seen. Back then, there were many more. Yet this also created a problem, the consequences of which are still with us. To cover the immense need for timber in the mines, fast-growing conifers were planted. Yet this species is highly vulnerable to wind breakage and pests such as the bark beetle. Back then, however, they had no choice. Apart from timber for mining, a brand new technology devours entire forests in next to no time.
I bid you welcome, my worthy colleague.
Steam, as a potential source of power, has been known about since ancient times.
Here, a special pot which, by using steam, will speed up the process of cooking.
The fact it can also be used to speed up cooking is first observed by a Frenchman, Denis Papin. In 1679, he experiments with a pressure cooker, alas, with explosive results. Only when Papin inserts a safety valve does his invention work.
Dass man diese Kraft aber so sehr
The harnessing of this force to a degree that it may serve in propulsion units is a development of the late 18th and 19th centuries. And with that, of course, you needed immense amounts of fuel to generate steam.
Diesen Dampf zu erzeugen.
Papin's valve opens up undreamt of possibilities in the use of vapor pressure. Steam engines and turbines become the driving force of the industrial age. Today, we have to deal with the consequences, as steam energy is produced in power plants fueled by coal, oil, or gas, the combustibles of the Anthropocene. They fire global warming, and they cause ever more glaciers to melt, a process that is accelerating fast. Since 1961, glaciers the world over have lost the incredible amount of 9,000 tons of ice. Whether by 2100 the sea level will have risen by 30 centimeters or by more than a meter depends on the degree to which we succeed in throttling global warming. One thing, however, is certain.
Sea level will rise, and what this will do is it will absolutely undermine agricultural productivity in most parts of the world. It will adversely affect water quantity and quality. It will affect our natural ecosystems. It will displace millions and tens of millions of people who live in small island states, deltaic areas.
The rise of the sea level can already be felt. For instance, in the Everglades at the southern tip of Florida. The river of grass, as the locals call it, is gravely endangered by environmental stress and man's interference with its hydrological balance. 85% of all wetland areas of our planet have already vanished. And here too, the flow of water is severely impacted by roads and canals. Added to that, there is the extraction of groundwater to supply the neighboring cities. Due to this, seawater is pushing into the cavities, and the Everglades are becoming oversalted.
The Everglades is the aquifer replenishment zone for all of South Florida. We rely on one main aquifer, that's the Biscayne Aquifer. The Biscayne Aquifer, however, has become inundated year after year during the spring king tides. When that happens, Miami Beach the last several years has been under salt water, because of how high the king tides have been. When that happens, that salt water has to trickle down through the substrate and into the aquifer. What connects the Everglades to the ocean is the aquifer under the ground. When the sea level rises and the Everglades does not come up equivalently, salt water comes underneath and infiltrates our aquifer,
which in turn threatens the supply of potable water to a metropolis like Miami. And this is not the only problem caused by rising sea levels. In many places, the sea is eating away the coastline. In the United States alone, real estate worth $500 million has been lost to erosion. 2/3 of all beaches in Southern California are doomed. Countermeasures have had only limited success as the sea level keeps rising. Coastal cities the world over are facing submersion. Disastrous floods are becoming ever more frequent. And yet we cling to the coast, almost as if it were our intention to challenge the sea.
Cities like Sydney, New York, Shanghai, Tianjin, Venice, these are all cities that are attached to the sea. You know, their infrastructure abuts right up to the sea. There's no space there for the water to come and the city to retreat. And so a lot of these places are building barriers or thinking about building barriers. But barriers can really only protect up to a point. And for a while, the Thames Barrier in London has protected London very successfully for many decades now. But the rise of sea level implies that they're right now building another one, because sea level rise, until we get this problem under control, is not going away. And if you're always building to keep up with what's happening, it's very, very difficult to adapt to a moving target.
The world over, millions of people are threatened by rising sea levels, and they have lost their homes by the end of the century. Some cities, like Male, the capital of the Maldives, have already begun to sink. Any attempt at coastal protection has proved to be in vain. Yet the rising sea level isn't the only threat in relation to the oceans. Lord Howe, a tiny group of islands some 600 kilometers from Sydney. Out here in the Pacific Ocean lies the southernmost tropical coral reef of our planet. A mere 400 people may visit the island each year. Conservation prevails, so it looks like a paradise, at least at first glance. Patcher Light, one of the most successful Australian surfers, is determined to draw our attention to the state of the oceans. To her, it's obvious what we owe to the sea.
Humans have come from the sea. You know, all life has come from the sea, so it's almost like a womb of a mother. So I like to think of it like that and treat the ocean as my mother and take care of her. And yeah, she gives us so much and she allows me to have fun every single day, and yeah, it's very special.
And the oceans do indeed need our help, as human leftovers weigh heavily on them, as well as on the fauna living in and close to the sea. Each day, biologists find dead fledglings along the beaches.
Nice.
Even before a closer examination, Jennifer Lavers of the Australian Adrift Lab suspects its cause of death. The autopsy confirms her guess.
Fabulous.
There's plastic in the stomach and in the intestines.
Looks like we've got one piece of plastic right there.
Pale-footed shearwater hunt in the sea and will devour anything afloat. The birds die less because of internal wounds caused by sharp-edged particles. They starve because their stomachs are stuffed with indigestible plastic, so that they can no longer take in any proper nourishment. Plastic threatens the actual dwellers of the sea as well. Patcher Light, the young activist, is a member of an environmental organization which points out the ever-growing spread of plastic.
This beautiful island covered in plastic. People on that island, it's not even their plastic. It's this plastic washed around the world, and yeah, I don't think there's any place that isn't covered with plastic now.
The substance starts out in rather unusual surroundings, in an American billiard saloon. In the mid-19th century, billiard balls are still made of ivory. They're not just expensive, they also quickly show signs of wear and tear. Tiny quirks which may influence their smooth running and are highly annoying to the players. The owner of a billiard saloon, Michael Phelan, finally promises a bounty.
$10,000 to anyone who can find a replacement for ivory.
The man who hits upon a solution is John Wesley Hyatt, a chemist. He succeeds in producing a mass from cellulose nitrate and camphor, which, among other things, can be used to form balls. However, celluloid, as it's called, has a grave flaw. The mix is inflammable and explosive, causing a great deal of alarm in the saloons, according to contemporary reports.
I'm sure we'll overcome this problem in time.
As so often in history, a promising invention has backfired badly. Each year, about 40 million tons of plastic end up in our rivers and oceans. A substance hailed because of its durability has turned into a nightmare. Across the world, hundreds of billions of plastic bags are used each year. Not least because we mostly use them only once and then throw them away. The wash of the waves and solar irradiance cause plastic to decay into ever smaller particles called microplastic. As such, it finds its way into the food chain, even where it's not produced at all, with unforeseeable consequences for man and beast. As night falls on Lord Howe, scientists and environmentalists prepare for a special rescue mission. They collect fledglings hiding in the scrubs while their parents are out looking for food.
Okay, next one, Alex.
Lord Howe is the only breeding site for these migratory birds along the eastern coast of Australia. During the past years, their number has decreased steadily. Today, they're considered an endangered species.
We collect the feathers from the birds. It takes only a quick moment because these couple of feathers can tell us a lot of really important information. When plastic is out floating in the ocean, it acts like a magnet or a sponge, and it concentrates pollutants onto its surface. And so when a seabird like this consumes that plastic, or a whale or a turtle, those chemicals leach out into the bloodstream and inevitably into the tissues, including feathers. And so I can send these off to the lab and figure out what chemicals this animal has been exposed to and whether or not that relates to the amount of plastic that I then find in the stomach. So something that is only a little bit painful and takes a brief second is actually incredibly informative for a scientist like me.
To save as many young birds as possible, the scientists perform an unusual operation on the fledglings. They pump their stomachs. Each one of them has plastic in its belly. This little guy alone has swallowed 13 pieces.
6, 7, 8, 9, 10, 11, 12, 13. Plastic and that huge piece of pumice, look at that.
Then it's off into the wild again, where, alas, more plastic awaits. Like no other substance, plastic illustrates the ongoing consequences of human inventions to our planet, which seem boundless, and from which there is no escape. Not even on a faraway island. More than 9 billion tons of plastics have been produced worldwide since 1950. Today, the biggest output comes from China.
Das Plastik
Plastic has had unforeseen consequences during the history of mankind. As a young student, I always thought that if we divide historical periods according to certain metals, the Copper Age, the Bronze Age, the Iron Age, we ought to talk of the Plastic or Synthetic Age if we refer to the era from the early 20th century onwards.
There are prognoses that in 2050 there will be more plastic in our oceans than fish. To keep this disastrous perspective from becoming a reality, an organization called Ocean Cleanup was founded in 2013. They've set themselves the task of fishing plastic from the oceans and out of the rivers which carry it into the sea. Other than in streams, collecting waste in the vastness of the oceans is a technical challenge. Driven by ocean currents around the world, plastic accumulates in 5 gigantic whirls. The largest is the size of Europe. First trials have proved an arduous undertaking. It's all the more important, therefore, to keep the oceans free of plastic in the first place.
We're probably creating a future that is hostile to human life, and we have a responsibility to ourselves and to our children and their children, but we also have a responsibility to the economy that we live in, which is the natural world, to do what we can to improve everybody's chances.
Students of the Australian Institute for Marine Science are searching the beaches for plastic. They're less interested in large, obvious fragments than in tiny particles, which are almost invisible to the eye. Microplastic. Since, according to studies, animals and humans are taking in ever more of it. Such as the tiny clownfish, a variety which inhabits the Great Barrier Reef by the thousand. A trial in the lab is intended to establish the amount of microplastic in its intake and how much of it accumulates in its stomach and its tissue, and to find out whether the clownfish is at all able to discern between its proper nourishment and the particles of plastic. The results are alarming.
I was very surprised when I first started this work on the Great Barrier Reef that we did find microplastic contamination in every water sample that we took and in most of the fish that we analysed.
To the naked eye, there is no microplastic to be seen in the stomach of the tiny fish. Research has shown that today, most of the microplastic consists of microfibers, which enter the oceans as residues when we wash our clothes. 10,000 microfibers weigh less than 1 gram, and they're just one source among many.
We know that microplastics come from sewage treatment plants, for example, but importantly it also comes from larger plastic waste that ends up in the oceans and on the beaches. And specifically on beaches they become very, very brittle very quickly due to being exposed to the sun and the salt, and they break down very quickly into smaller and smaller bits until eventually they turn into microplastics.
The high-end microscope confirms the intestines of the clownfish were filled with microfibers. Yet plastic is only one problem that affects the Great Barrier Reef these days. It has become the realm of the White Death, coral bleaching. Corals are cnidarians and live in symbiosis with algae, which provide them with food. If the water gets too warm, however, the algae begin producing poisonous molecules, provoking the corals to shed their cohabitants. As they're now without their food providers, they die.
The first thing that you see on a reef that has bleached, that has been exposed to high temperatures, is all of the individuals going white and all of these other fluorescent colours. So in the early stages of a bleaching event, it's quite a spectacular and beautiful phenomenon. But these colours are the colours of death. The fish life has disappeared. All the small damselfish that typically live within the branches of living coral have gone. So it really does feel like swimming through a graveyard with the tombstones still intact. What our study shows is the corals, they're not being replaced. And so if they're not replaced, eventually they'll all die out. And so that's the real worry about our study. We never expected this process of recruitment to fail. And we never expected it to fail on the scale that it has.
Too big to fail. That's what scientists long thought about the Great Barrier Reef. Now its ecosystem is in for the worst. At the Australian Institute for Marine Science, AIMS for short, they're looking for a way out. The scientists place their hopes on resistant corals, which can stand higher temperatures. Like fish, corals reproduce by ovocytes. These then turn into larvae that drift in the sea until they settle down. At the lab, they provide the corals with pieces of limestone as their new settlements.
And we can advance?
Whether these efforts prove successful can't be verified by the naked eye. It takes an electron microscope to do that. Yet each new coral that settles on the limestone promises an option for saving the reefs. The tiny white dots are rays of hope, corals in the earliest stage of growth. However, whether the scientists at AIMS can ensure the survival of the Great Barrier Reef remains doubtful. Because the survival of a reef doesn't depend on local conditions alone. Coral Bay on Australia's west coast. Park ranger Peter Barnes and marine biologist Mick O'Leary are checking the state of coral reefs at the other end of the continent.
That's really interesting. We did an aerial flight.
Coral Bay is part of the Ningaloo Reef, also part of the UNESCO World Heritage. Its corals are among the most beautiful and the most intact specimens in the world. While Peter Barnes gets ready to check if the corals are adopting their new home, Mick O'Leary is on his way to a problematic spot near the coast to see if here too coral bleaching has set in. The biologist knows that no place is spared from climate change.
I'm afraid that the Ningaloo Reef will follow the same trajectory that we're seeing in coral reefs around the world. The collapse of corals in the Great Barrier Reef, in the Caribbean. The corals here are in a pristine state. There's little impact locally, but what's happening in Europe, what's happening in North America, increases in atmospheric CO2 going to lead to increases in ocean temperatures, and that's going to have an impact right here in Ningaloo.
Mick O'Leary closely examines this section of the reef, comparing its present state to old photographs. The corals don't seem to have changed their appearance. It's good news. Up until now, the reef has been able to regenerate time and again, since there were sufficient interludes between phases of coral bleaching. It takes 10 years, says O'Leary, before a reef has overcome a period of bleaching. Coral Bay has been spared larger outbreaks in the recent past. Yet, if such events were to occur with mounting frequency because of higher water temperatures, as feared, the reef doesn't stand much of a chance. Then, new corals won't have enough time to settle. So it's important to know how many coral larvae take hold after spawning. Their quota is decisive for whether a reef will live or die.
After the coral spawn, we've got all these coral larvae that go up into the water column that might swim around for a couple of days or a few weeks, and then they find a nice bit of habitat and settle on it. And what we use to count how many corals are actually settling are these little settlement tiles. So we've had them out there from before the coral spawn. We've just gone and picked them up. We'll take them back to the lab, have a look at the tiny little corals that are on there, look at what species there are and how many there are.
First results are encouraging. The reefs of Coral Bay produce enough offspring that settle down. Alas, this is not the case in all regions of the Ningaloo Reef, which stretches over 260 kilometers along the west coast. In some places, there's a serious lack of larvae, and as a consequence, an insufficient number of young corals. It all depends on whether worldwide CO2 emissions increase. If they do, things don't look good for this underwater paradise.
The UNESCO prediction of Ningaloo ceasing to have a functional reef system by 2041 is indeed extremely alarming. The important thing for us at the moment is to build resilience in these systems. The world's going to change, the climate's going to change. We want to make the systems we've got at the moment as resilient as possible to those changes.
The rising sea level also keeps the reefs from breaking the waves, and thus they no longer protect the beaches, which are gradually being washed away. In addition, we're building ever closer to the shoreland, thereby depriving the surf of any leeway and causing more and more sand to be drawn into the sea. Many houses along the coast are in danger. Hundreds of beaches have to be regularly filled up. Across the world, more than 3/4 of all beaches are threatened by sand loss. Since the more we build, the more sand we need. However, not all sand is the same. If you want to build, it must be of a rough variety. Only this way will it provide grip and proper cohesion. In the desert, for instance, sand corns are ground into a round shape by wind, so they're no use in concrete or mortar. The gigantic construction projects in the Arab world depend on sand from other areas of our planet. Within the past 20 years, demand for sand and gravel has tripled. Building your average single-family house requires about 200 tons of sand. Our world is literally built on sand. We use about 40 billion tons of sand and gravel annually to produce concrete, an amount sufficient to erect a wall around the world, 27 meters high and wide. For centuries, we humans have used the natural resources provided to us by our environment. Yet the increasing world population's hunger for sand prompts illegal extraction, such as here in Ethiopia. The sand trade has become big business, with profits in the billions. Yet those first in the chain profit the least. The extraction of fluvial sediments has grave consequences. Rivers transport sand to the sea. They wash up new material to the coasts and thereby regularly fill up the beaches. A natural cycle which is interrupted by us, and not just by extracting sand. We've also barred the sand flow with no less than 850,000 dams worldwide. They change the course of rivers and harm the population of fish. That's why they've come in for criticism, even if they do provide us with clean energy. Yet, when it comes to water as an element, there are more issues than just sand, potable water, or rising sea levels, each of which already now affects hundreds of millions of people. The central question is, how much room are we willing to concede to our planet in the future? and whether this will be enough to conserve our world as we know and love it. What's at stake is graphically illustrated by those reefs which are still intact, such as Australia's Ningaloo Reef. Coral reefs, like the rainforests, are the most biodiverse regions of our planet. Over thousands of years, they've unfolded their magic at the bottom of the seas, undisturbed by man. It's up to us whether they continue to do so. In spite of all that we've inflicted upon nature, the age of man, for the first time, has created possibilities for making their charms visible to all. And thus, to drive home to us what we may lose if we don't act. Never before have so many people seen so much of the world's beauty and its diversity. It's a chance for us. Even if the challenges ahead are gigantic, we must, more than ever, learn to live in harmony with nature.
Without the environment, there is no culture. Without the environment, there is no human history. And certainly without a viable environment, there is no human future. And we're in a dance together.